Lecture 8.1, Introducing ROS Services. So we're now in Chapter 8 on, you guessed it, ROS Services. So just a couple lectures. Lecture 1 will be on an introduction, and then Lecture 2 will actually implement a couple, a service, a server and a client. So that's this chapter. Pretty short chapter, but important nonetheless. A ROS service is effectively a function one node, the server, provides to other nodes, the clients. And then I just got cute with it. In box 8.1, ICANN has service, a script, like for a screenplay or, you know, a play on a stage. So pretty much, if we have node A, which is the server, and node B, which is a client, node A says, yo, I can do X service, which is to say it registers a service. Of course, ROS core is involved there. Node B is like, hey, node A, do X for me, please. So it requests a service and waits. And then node A is like, yeah, I'll do X for you. And service occurs. And node A is like, here's the result of doing X for you. And node B is like, thanks, fam. And which, of course, I just assume happens because, you know, the nodes are polite to each other. Nothing else. The key aspects of services is that they are synchronous. A client waits, doing nothing else, while the server services it. So obviously, this only works well for tasks that take a limited amount of time, such as 1, getting a sensor value, 2, setting a parameter, or 3, performing a computation. So these are common things that we might do with a service. We'll talk about actions in the next chapter. And that's something that happens asynchronously and might take, you know, some long amount of time. So these are relatively short amounts of time because the client's just waiting for this service to be served. And they're typically sort of finite but synchronous. They happen right away. So talk a little bit more about it. An example. In this section, we develop a custom service type definition, word count. And we're going to put it in serve/wordcount.serve for a service that has as input a string and as output the number of words in that string. We create a new package for this chapter, My Services, which shadows the package included with the book, Rico Services. So this is a package that you have from the book, or from downloading or forking my repository. So use in your workspace's source directory catkin create package to create a package as follows. So let's go ahead and do this simultaneously. We're in the workspace source directory. We're in the repository example that I've been using to work on, or to make packages that we've created together. So if I ls, we see the My Topics package is there. So we'll also add a My Services package now. So use catkin create package My Services, and then ROS CPP, which is just a C++ one, ROS Pi, message generation. These are all of the dependencies, and message runtime. So these are ones we've used before. ROS CPP and ROS Pi are in most packages. We don't always need to call ROS CPP when we're using ROS Pi, but sometimes we'll need it, so it can be a good idea to include it in the create. So now we have a new package. Well, if we ls, we see it. So now if we bop down into my services, we've got just a nice clean new package for us. Great. So we're gonna create a custom service definition file, which is a little bit like a custom message definition file. So we'll do that first. So from your package root, create it with the following. So we're in our package root. So we'll make dir the srv directory. Okay, so now it's in there just like msg or src. Now we have an srv, our services directory. Technically we don't have to call it that, but it's nice to use that because that's pretty standard. It's a common convention people use. So touch srv word count dot srv will create the definition file, and then we can edit it using whichever editor we like, Sublime Text being of course my favorite, and that will open up. Okay, so now we're ready for that. Let's see what it says about what to put in there. We can edit the contents of wordCount.srv to include the following. So we have a field type and then a field name, just like in the message definition file. Then we have these 3 dashes, and then we have another field type and another field name. So how this works is above the dashes are the delimiter that says, that signals that we're moving from inputs to outputs. But it's very similar to a message definition in that we just list out field types and names of inputs above those 3 dashes, and then input types and names of outputs below those 3 dashes. So pretty straightforward. We're just going to do string words. So we're going to use standard messages package types here for our fields. So string words and uint32 count. String words 1, 2, 3 uint32 count. Okay, so this means in the input we're going to have words come in. It's going to be a string. And then on the output we're going to have an integer, 32-bit integer, and it's going to be called count, which is of course going to be the word count for us. We'll save that, and we go back to our handy instructions, and they say, hey, you're ready to update the build system. So remember, just as when we did our new message, our custom message, we had to update our build system, meaning specifically our package.xml and our cmakelists.txt. So we'll have to do that again in this situation. So the package we're creating in this chapter, My Services, was created with a bit of forethought because we knew we were going to do this. We included as dependencies in our cat can create package call the packages message runtime and message generation. If we hadn't had such foresight, we would have to make several changes in our packages, package.xml and cmakelists.txt files before proceeding to create our own message description. As it stands, we still need to make a few changes to them. So here we go. So for the package XML, including message runtime and message generation, yielded these two. This is actually, I think, identical, if not very, very similar. I think it's identical to what we had to do with the package.xml file when we had a custom message type that we defined. So we do still need to add message runtime as a build depend. So copy this here, and we're going to want to open up that package.xml file. We're still in the package root, so package.xml should be right here. So we can subl package.xml, and the usual stuff is in there when we use our can create package. We need to add as a build depend, so we'll put it right here, that line, so message runtime. Okay, so that's all we needed from that. And the other file, cmakelists.txt, has the following involved. So including message runtime and message generation in our cat can create package yielded the following lines in our cmakelists, which would otherwise need to be added manually. So we would have to add this message generation to find package. The rest of the changes we do need to make manually. We have to find the add service files block and uncomment it and add our word count.srv file there. So let's subl our cmakelists.txt, and we need to find our add service files. So add service files, there it is, and we need to uncomment this, so there. We'll delete those pound signs, and that will give us this uncommented block, but service 1 and service 2 are there as just placeholders. We want word count.srv. Great. And we've got one more thing, I believe, to change in here. We've already created this word count.srv file. So we have the generate messages block, which needs to be uncommented, and nothing needs to be edited in it, but we just need to uncomment it. So generate messages. So we'll go over here, and the generate messages is actually just right below here. So, whoops. Okay. So we can again just uncomment this block here and save our cmakelist. Whoa, that was not what I wanted. Just save. Don't type a bunch of S's. All right, so that is our cmakelists.txt. So our build system is now in good shape. We've got it all updated, and we can cat can make to make that service available. So let's go ahead and do that. Let's I'm gonna use this tab to go to our workspace root, and I can use cat can make here 100. Okay, so the clock skew warning is not a big deal. You might see that sometimes. And we are now happy that our package has got this service that's been properly built and we're able to use it now. So what I need to do is actually source my workspace, which I can do from here actually. If I just say, okay, it's 1 level up to example, 2 levels up to source, and then it's in devel. Did I get up high enough? Maybe one more up. To devel, there we go. To the workspace, and then to devel, and then setup dot bash. So we've sourced it, so now everything's available to this terminal. So all of our new stuff is available to this terminal. So the package ROS MSG, which we've already used and installed, includes the command ROS serve, or ROS SRV, which gives information about services. So if you just type in ROS serve, it gives you this nice help thing here, which tells you the different things that ROS serve will do in a sort of compact form. It's pretty nice. So we can show a service description, a specific service description. We can look for a list of all services. So we could say ROS serve list, and we would get, gotta spell it right. And we would get a whole bunch of possible messages that we could use. And let's just, since we're here, let's see. Look for my services, word count, there it is. Heyo. So great. But we want to see what the service definition is for word count. So let's use ROS serve show word count. And it finds, so these were some of the old code, so that's why chapter 23 and chapter 4 show up here. They defined a word count as well. My services word count, this is the one we just created here. And then here's the one that the book code has created. So it finds each one called word count. So that is how to use ROS serve a little bit to explore what we've created for our service. So it's working, it's available, and we've successfully created a service type. So in lecture 8.2, the next lecture, we'll learn to serve and call this service type word count.